No. So we have that quiz today. It is on chapter 6 and 7. Um, the formulas are on the. Oh, that's right. I just realized something. All right, I'm gonna have to. I don't know. I put the formulas on the quiz, and of course, I forgot one, which is such a great thing to do. Um, Let me think. So at some point, I'm gonna have to get in there and update it. I don't know how I'm gonna do that. Maybe I'll put it in the notes. I don't know. So we got that quiz today. It's due tomorrow at 6. So I figure I normally like to give about 24 hours for a quiz, and I gave a couple more hours just because, in case anybody has weird jobs and stuff. So are there questions? There is one I'm going to do in a minute, but let's see if it comes up naturally. Questions from chapter 6, chapter 7, or the practice quiz or anything? I don't believe that. I'm not even, I don't believe it. So we'll do the I'll ask a question for you. Hey, Mr. Waller, what the shit is 97 about? All right. Watch your tone, young man. I'm sorry, Mr. Waller. Okay. Um, this one. This one is such a beautifully evil problem. I love it. I love it. And here's the thing. Here is the thing. I don't know how you guys think about homework. Homework is not given to you with the expectation that you'll do it perfectly. That's insane. Homework is practice. And what happens when you practice something? You make mistakes, right? So this whole stigma about I don't want to ask because that would then he's gonna know I didn't know what I was doing. I'm like, well, that's the whole point. How the hell would you know what you're doing when you're first practicing something, right? You should see me when I was trying to learn how to play guitar. First practice sessions were horrific, and I haven't tried it since. I suck. Anyway, so this one is definitely strange, and to talk about it, does this sound familiar to anybody? There are several people I've graded. I cannot remember anyone getting it. Maybe one person got it right. I can't remember now. All right, so let's take a step back in time. A little side note. All right, let's say the probability that I make a free throw. Playing basketball, right? Probability that I make a free throw. Let's say it's 60% chance, right? 60%. And I take 20 free throws. How would you calculate the expected free throws made? So I think this is free throws. Expected free throws. Good Lord, Jeff. How would I calculate the expected number of free throws? Expected value of my free throws made. Does that sound familiar to anybody?
Would it be mean plus z score
No, no,
times
no, 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 no.
Okay.
I don't know the mean. That's the problem. Another name for the expected value is mean. Do you guys remember? Remember this formula? This is not the formula I'm going to use here. Remember that formula? EXP, expected value. All right, I'm not going to use that one here. I'm going to use, all right, what's 20? What variable would I use for 20? I'm taking 20 free throws. So what letter would be 20, would represent 20?
N.
N. So N is 20. And the probability to make a free throw is 60%. What letter do you think I should use for the probability of successfully making a free throw? Successfully, a probability of a successfully made free throw, P. What was the formula for the mean? N times P. Do you guys remember that beautiful little tiny formula? You guys remember that? No? So if I know the probability of something occurring and I know the number of times I do the thing, I can figure out the expected number of times I'll do it successfully. So what is the expected number of rejected coins when 280, okay, that's N. So all I don't know is the probability of one coin being rejected. Then it would be the exact same as this. Here I knew the probability of making a free throw, and I knew how many free throws I was going to take. So I could calculate the expected number of free throws made. Here, I know how many coins I've got. To figure out the expected number of rejected coins, I have to know what's the probability that a coin is rejected. So now I can focus all my attention on this. And once I get this, this will be P. I can multiply it by my N. Done. So what a lot of you guys were doing, and I don't blame you, is you were dividing this by the square root of 280 and all kinds of shit, and you were getting z equals negative 23 and z equals 23, and then somehow this became coins instead of a z-score, which is neat. And this is negative 23 coins, but nobody had a problem. I'm sorry. I'm ranting at you a little bit. But you have to step back. Don't just, I don't know if anybody saw that the answer is like 47 or something, and you thought, that's close, that must be it. But this is a z-score, it's not coins, it's a freaking z-score. Is this an insane z-score? Everybody should know that's an insane, 3 is a pretty crazy z-score already. I'm about to die, hold on, I gotta take a drink. Holy crap. No idea what just happened to me. 3 is a crazy z-score, right? Because unusual starts at 2. So 23 means you did something wrong, almost definitely. Okay, now. This problem becomes a chapter 6 problem. What's the probability that one of these is rejected? And this problem, this book has a problem with saying it's normally distributed. Gather. Normal distribution. When is a coin accepted? When is a coin accepted in this vending machine?
The range of 5.1112 to 5.291 grams.
I like it. So when is it rejected? Good Lord, Jeff. When is it rejected?
When it doesn't fit within that distribution.
Yeah, when it's not in there. So these are the rejected coins out here. Does everybody agree with me? Those are the rejected coins. So all you got to do is figure out what those areas are, add them up, and you got P. Right? Then you get P. And then you come over here and you go, okay, N times P equals answer. Homework finished. Yay. Now, listen. Don't listen to my tone right now. This is a difficult problem. Really difficult. It's difficult to realize this is what it's asking, correct? It is. It just is. So don't take this as if it's some kind of barometer of how well you did in this section. This is a bonus question. This is a freaky question. And that's going to happen. It just is. It's just going to happen. I'm sorry. It just happens, right? Well, you assigned it, Jeff. I sure did. So I'm going to make it happen because I'm an asshole. But no, I also want to make sure that I want to see who can think out of the box, who can do this kind of stuff. But you don't take it to mean that you don't know what's going on. If that's the only problem you had a lot of trouble with, that means you're doing fantastic. Right? So now you know what to do here. Hopefully make z-scores out of this. You know the mean, you know the standard deviation. You make z-scores, you look up the z-scores, you get the area there. You got to do 1 minus to get the area there. That gives you your probability of a rejected coin. And then you multiply it by 280 to see the expected number of rejected coins. Okay. Okay. Oh shit, I got some chats. I'm sorry. Somebody's telling me answers. I'm not paying attention. All right. Any other questions from homework? Everybody's just ready for that quiz tonight or tomorrow, depending on when you take it.
I was confused on 64 when it was asking to find the median.
All right, I'm going to clear all this away. Here it goes. All right, 64. Oh yeah, this one is evil. All right, you ready? Now listen to me. Listen. This is the easiest question ever, but don't feel bad because they put it as part D, which makes you feel like there's a lot of work to do. What kind of distribution are you working with for the average of 49 race times? What kind of distribution is that? You already answered it up here.
Normal.
Normal. In a normal curve, how do the mean and the median and the mode relate to each other? Wow! So the mean is right in the middle. Where's the median? Come on. Somebody help. It's also in the middle. Isn't the mean cutting everything directly in half in a normal curve, right? Doesn't the mean cut it in half? Yes? And isn't that what median means? The number that cuts your data directly in half. There's half of it above and half of it below. So that's why this problem, and again, this is evil because it's so damn easy, but they put it at part D on number 64. So you're kind of expecting it to be a lot of work when really you already know the answer. You knew the answer from the beginning. Does that make sense, guys? It's just kind of rechecking that you remember that for a normal curve, the mean equals the median equals the mode for a normal distribution. Is that okay? Is that all right? Are you? I don't blame you if you're angry about that. You're like, God damn it, I did all this work. I understand.
But like if we get asked that, then doing the work out to find it, because you're gonna probably be like, how did you figure this out? If we just wrote,
If I ask this question in a problem like this, then you would just say normal means the median
okay,
equals mean. So 145, Jeff. Take that answer. No.
we want to make sure we wrote it correctly, because
See, this is what people don't. I understand when I'm always like show work, and a lot of you guys are like, if this guy says show work to me one more time, I'm gonna go insane. And all you got to do is show me the damn work, and I'll stop saying it to you. But this is a conceptual problem, right? The only work I need to see is to say I know the median equals the mean in a normal distribution, Jeff. So then it's 145. Bam! You've shown me the work. Now, some of you guys need to realize writing normal CDF, if I see this shit anymore, I'm going to go insane myself. And then your grade's going to go way down. No. Have you ever met me? You guys should know by now that I don't like answers coming from buttons being pushed, right? If you have an issue with that, you have taken the wrong teacher. I'm sorry. You've chosen poorly. Okay. So I'm still seeing way too much inverse norm and normal CDF bullshit. So there's nothing wrong with checking your work. Nothing wrong with checking your work. Throw that in the calculator. Check it away. Check, check, check. But you got to do the work in the first place to check it. Okay. All right. And thankfully, nobody said to me yet, but my last stats teacher, I don't want to, no, you don't have that person anymore. All right, I'll stop. I feel very ranty today, and I'm sorry. I apologize. Anything else from homework that I can rant about?
In 7.1, number 65, letter F. Did someone ask that already?
Yes. I can't remember when that was though. It feels like recently, but yeah.
QR.
What is yeah. So what is interquartile range?
So it'd be the 0.75 of, because, yeah.
So it's from Q1 to Q3 is the way they're kind of wanting it. Does that make sense?
Mhm.
And in part E, you've already figured out Q1.
Yeah, that's what I, okay.
Now F you just figure out Q3. Yeah.
Okay.
Cool. All right. I like it. All right, guys. Okay, it seems like maybe so everybody's good? Relatively?
Do we have to draw the graph to show the answer?
So you really don't have to. You can show you the work in different ways than putting it on the graph. So as
Yeah.
long as you show appropriate amount of work, that's fine. I just will remind you that the people that make the mistakes are normally the people that don't draw the picture. I'm not saying you have to. You don't have to. No. Okay. All right, guys. So let's get back into what we were doing last time, which was we finished this sheet here. So we're back in chapter 8. You guys remember the sheet about the dolphins and the little cove? Okay. All right, so we did all this beautiful work. So what I want to do is I got to turn off my kick-ass. Look at my background. Isn't that kick-ass? I can't. Why can't I get it to work? There it is. Anyway, sorry. I did not take that and do anything with that. I just found it and stole it. Let me turn this off. I'm going to get up on the board. We're going to discuss some concept. Jeff and his freaking concept. Rawr. All right. So, what's kind of cool, let's remember how we did, how did we get to the formula that we use in section 8.1? Oh, you turned off. That's why it's so dark in here. Look at that trigonometry. Oh, sorry. All right. So, section 8.1 was confidence intervals for a mean. And what we did was we started with, you can do it, Jeff, mu plus z sigma. Okay, stay with me now, stay with me. And we said, okay, what if we don't know this? What if all we have is x bar, which means we must have taken a sample, so then this has to change. And then if I go up and down so many of these, so many z-score, so many of these steps, then I will catch a certain percentage of data. So that's how we create intervals that we have such and so much confidence in. Does that sound at all familiar? This is the whole thing that we talked about, and then we did the dolphins problem. Okay. All right, so what we're going to do, so section 8.3, we're going to start off in the exact same way. We're going to start with mu plus z sigma. Actually, let me do this. Let me erase 8.1. You're going to go away 8.1. So that was the formula we got from section 8.1 to create a confidence interval for a mean when I know the population standard deviation. Okay. I'm going to erase this. I'm going to start over again up here. So section 8.3, and again, remember, what happened to 8.2? We're going to do it next because it's got a new chart. It's got a new chart. Yay! Section 8.3 still uses the z-score chart, which is nice. So we're going to start here, but what we're going to do, all right, how do I say this? All right, so we're going to go, all right, let's see. How do I want to start this? I always teach this a little differently, so I'm trying to figure out which way I want to do it. I don't think any way is better. So, all right. So when I let me see. So when we did 8.1, maybe this will be better. All right, I like this way. So when we did 8.1 and we changed this to be the counterparts for taking a sample and getting a sample mean, we're using it to try to capture the real mean. Let me see if you guys are cool with me writing this like this. So this, what is the purpose of this? Is to be such and so confident that I actually capture the real mean in it. Does that sound familiar? When we write our conclusion, we say we are this confident that our interval catches the true mean or contains the true mean. Yes. Maybe. See, okay, thank you. Gracias. In 8.3, what we want to do is we actually want to capture the percentage. 8.3 is all about creating confidence intervals for percentages. So do you guys remember last year, do you remember there was this thing, the election? Do you guys remember that? Do you guys remember that? There was an election last year? No? Yeah, all right, I don't blame you. You're like, I don't pay attention because it's just frustrating. I understand. But there was an election and you would see stuff on the news like 42% want to vote for this person and 48% want to vote for that person. We'll say person T and person B, just to pick some random letters. But at the bottom of the thing, you would see like plus or minus 4%. Did anyone ever see that anywhere at all? Yeah, like I have no idea. All right. It's possible you survive without seeing that ever. But you see this almost all the time when you have reports of statistical findings. You see this plus or minus something at the bottom. So we're actually going to figure out now we know what that is already. That is the error, right? That's the error, give or take. Give or take 4%. Couldn't this race be going the other way? If this is up 4 and that's down 4, isn't person T winning then? You guys get that? Yes, and that was 2016. That's what happened. But anyway, that's when it was person C, I guess I should say. All right. So we're going to actually figure out how to get that plus or minus 4% or whatever it's going to be. So what's the formula for the mean if I'm taking a certain number of people and there's a certain probability of success? Right, because 8.3 is all about percentages. So a percentage of a number, what's the formula? We just used it. What's the formula for the mean? What's the formula for the mean in this case?
N times P.
N times P, I like it. So NP is captured. Now, all right. So I'm gonna skip that, what this becomes. What's the standard deviation for this case? NP, I'll say NPQ problem, right? NPQ problem, where I have a number, this percentage vote for the person, this percentage vote for the other person. So it's probably a success, probably a failure. What's the formula for the standard deviation? Anybody remember? You got NP and the square root of N. No? Does that sound familiar? Yes? Okay. Just nobody wanted to tell me? Fine. Like, you're the teacher, man. You get paid to talk. Pay me and I'll talk. I'm like, damn, all right, shit. So I'm going to put right here plus or minus Z. times the square root of n. Oh yeah, that's right. I gotta stop for a second. So I'm not gonna tell you these yet either, because, all right, stay with me now, stay with me. So again, I started with the same formula, same kind of idea, except here's what's different. All right. Every time I do this, I do it different. This is almost a good way to do it. P is a percentage of a population. Now, when pollsters call people up and ask them who they're going to vote for, right? And you jokingly say Kanye, or maybe you did vote for Kanye. I don't know. Anybody vote for Kanye? I don't know if I want to know. Okay. When pollsters call people up, are they calling everybody in the population? So when they get the percentage of people that say yes, which would be the probability of success, should we give it the letter P? No, because it's not of the population, is it? I like it. So what do we, so watch this, it's kind of cool. I'm just going to tell you, for the percentage of a sample, you're going to love this. The percentage of a sample, the letter that gets is P with a little party hat on, and we actually call it P hat. P hat, right? Not fat. P hat. Okay. Which is the hat that you probably don't want to wear. P hat. It kind of makes sense. How do I say a sample mean? Isn't that with an X with a bar in its head? It's got a flat hat, and this has got a party hat. So if it's got a hat on, it seems to be a sample thing anyway. All right, so now watch. So therefore, if the mean is n times, if the population mean is n times the population percentage, what's the sample mean? It's n times the sample percentage. So what's going to have to go in here is going to be party P and party Q, right? P hat and Q hat. All right, now let me kind of go over that a little bit again. I really want this, and again, it's nice if this makes sense, but you don't have to know all the stuff that went into it to do the problems. But still, I still started with this formula. I don't know the population mean, so I have to use the sample mean, n times sample percentage. Sigma is going to be, I don't know the standards, the standard deviation of the population, so this is the P hat Q hat that makes this the standard deviation of the sample. Is everybody semi with me? Sort of like I had to put a standard deviation of the sample means here, yes? So I put a sample mean here instead of a mean. Did the same thing. I put a sample standard deviation here instead of the I did the same thing. All right, so I can just feel you guys slipping away. Just try to stay with me. I know this is weird shit. This still doesn't do what I want it to do. This captures a mean. Don't I want it to capture a percentage? Don't I want to tell somebody I think that the percentage, this percentage, that percentage contains the real percentage? It currently has means. Don't I want to get rid of n. I want this thing just to capture the percentages. And right now it captures the freaking means. So I'm just going to divide everything by n. Just get rid of n. Yeah, why have I circled this thing? I don't know. So just remind you guys, we're in the middle of creating a formula. You're never going to have to do this by yourself. Yes? You're not going to have to explain this to me by yourself. But I really hope it's making a little bit of sense. It's kind of nice. We started in the same exact place. We're just trying to write it in terms of NPs and Qs, so I can talk about percentages. So now I'll do this first part. So now I'm capturing the percentage, the population percentage is going to be captured by the sample percentage. Cool. give or take this thing. How, what? Excuse me. Can I just kill those ends? Can I just cancel those? Like I cancel these ends. Look at that. Look, Jeff. What? Can I cancel again? I'm just going to cancel them. Can I do it? If anyone can, you can, Jeff. Can I just kill these ends? Why? Let me ask it like this. Why can I not cancel those ends?
Is it because it's square rooted?
Yes. This is a whole end. Isn't this half of an n? Does that make sense to say that? What's the square root of a number? Isn't it half of the number in a way, right? Does anyone remember that a square root is a 1/2 power? Does that sound familiar to anybody? So it is technically half of an n. So of course they can't cancel. So what the shit? I can still do something. Tell me this. What's the square root of a squared? If a is positive, what's the square root of a squared? Come on, you can do it. What's the square root of a squared? You could do it. A. So what's the square root of n squared?
N.
N. Holy shit. So what can I replace n with? I can replace it with the square root of n squared. I just wrote the same thing. I love you guys. You're really turning off now. I can feel it. You're all like, I tried to stay with you, Jeff. I don't know what the shit this had to do with anything. Now, we're almost there. All right, we're almost there. Let me write this up here. Now, I can write this as one big ass square root. You can just suck everybody into it. And then what can I do now? What am I completely allowed to do now?
Cancel the N.
Well, sort of. How many ends? So that end dies, and one of these ends die, right? So I end up with, here's the formula. P hat plus or minus Z times the square root of P hat Q hat over N. Dadgummit. Okay. Ermagerd. All right, so let's do a concrete example together, right? Enough of this conceptual stuff. Here comes a concrete example. I'm gonna erase all this.
Wait, can you give me a second, please?
Sure.
You're good. Thank you.
So let's say we talk to 78 people, and 68 of them are planning on being vaccinated. Right? So hopefully nobody out there is like, yeah, a bunch of sheep. All right, whatever. Sorry, I don't know if you guys have run into these people. You're a sheep. You're gonna shut the hell up. I'm rational. I think that's what sheep means nowadays. Anyway, I'm sorry. I'm feeling very ranty today. I apologize. We talked to 78 people, and 68 of them are going to be or are vaccinated. Yeah, all right. Find the 95% confidence interval for the true percentage of people who will be plan on, or just say who will be vaccinated. So everybody with the question, does that question make sense? Okay, all right. Now, here's a huge thing that I inevitably completely forget to talk about until I've written a problem down. But maybe this is fine. This is motivation. What do I need to know before I can take this and change it into this? What must be true before I can take this and change it into a z-score? What do I have to use? Sorry.
It has to be normally distributed.
Yes, it must be normally distributed. Is this a question about sample means?
Yes.
Where? Where is it a question about sample means?
60 are going to be vaccinated or are
That's not a
no.
sample mean. That's not a sample mean. Does this question talk about means at all anywhere?
No.
No. If it was a question about sample means, what's n?
78.
That's greater than 30, right? We would be done with that part. We could just start doing the problem. But is this a question about sample means? No. So the whole thing about n greater than 30 does not apply here. Damn. Damn. Do you guys follow what I'm saying at all? I mean, I think at this point, hopefully you guys are pretty comfortable about looking to make sure n is greater than 30 to show that it's normal when I'm talking about the sample means, correct? There should be like it's a pretty, you're all like, well, yeah, I don't know. But that's not going to work. This is not sample means. These are sample percentages. So I don't currently have a way to tell if an NPQ situation is normal enough. Damn. So let's do this. Well, look, I got chemistry. All right. Yes, I tutored chemistry, but only small parts of it. Okay. Now, this is going to get interesting. Let me think. What's the... Yeah, let's do this. All right. This is going to be a little easier, I think. I have this really nifty handout that I don't think I did with you guys. Some semesters I do it and some I don't. But this is a good time to bring it up. Let me find it here real quick. Sorry. Oh. How about getting ready for class before class, Jeff? Be quiet. Let me see. Where are you? Here it is. Perfect. No, that's not it. I was so hopeful. All right, hold on. It's not here. Damn it. Hold on. You guys talk amongst yourselves.
So how's everyone day going?
Let's see if they talk.
Good.
Here we go.
How's your day going?
I overslept. I just woke up not too long ago.
Same.
Where is this? Sorry, guys. All right, let's see. Looks like I haven't used it in a while. Where are you? All right, I'm gonna find it.
It's good we believe in you.
Is this it? Probably not. Yes, it is. Hey, all right. I gotta have a little faith. All right. So let me save this as that. Put it in the right place. Oh my God. Everything's so crazy. Okay, here we go. All right, good. Here we go. All right, so here's something. I really don't know why I didn't use this, but I just didn't. All right. So what this is, so sometimes I'll use this in between chapter 4 and chapter 5, 6. That's the whole purpose of this. But if I flip a coin 14 times, what would be the expected number of heads? Flip a coin 14 times. What's the expected number of heads?
7.
7. Okay, so this is what this picture captures that idea. The expected number of heads is 7. But then it can go 6 is going to be a little less likely and 5 is going to be less likely and so forth, right? So everybody with me? So this is a binomial distribution, of course, right? Flipping a coin is like the most basic example of a binomial distribution. Stay with me, stay with me, stay with me, stay with me. Does this look like it's normally distributed? Come
Yes.
on, you can do it. Yes, totally. It looks really nice and normal, doesn't it? All right. So why does it do that? Well, now I really want this to make sense. What if this coin had been weighted? No, Jeff, you can't do it that way, buddy. Using the wrong eraser. There you go. What if this coin had been weighted so that the actual probability of getting ahead was 10%? Right? So this is what it looks like if the coin is not weighted. It's just a normal coin. Nothing's weird with it. It hasn't been weighted, anything. But let's say somebody did weight it so that it was a higher chance to be a tail, less chance to be a head. So 10% chance of a head. You with me? So what is the expected number of heads then out of 14 flips? You can do it.
Like 8?
No. What's N? What's N?
Like 2?
Almost. Not really. No.
1.4?
What is happening right now? Yeah, I think you said 1.4, right? I'm sorry. I thought for a second you said 10.4, and I was getting really concerned. N is 14, doing it 14 times. P is 0.1, 10% chance. So the expected number of heads would be 1.4. Okay, I like it. Which means if you flip a coin 14 times, if you flip this coin 14 times, but then you flip it 14 times again, and 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 you do that like a million times, you'll get an average of 1.4 heads for every 14 flips. You guys with me? So in this case, so this picture is if it is a normal coin, it has not been weighted. The highest peak will be right in the middle because it's evenly spread out. It's 50-50 chance. Where will the highest peak be for this coin? Around what? Well, what's the mean of this?
1.4.
So the highest peak should be around 1, right? So this picture would look like this. Let me see. Can I do this? Let's try it. That's right. I can't do it with this. All right, I'm going to use this other thing. Get out of here. Stop it. I'm going to use the one I don't like, but this is the one thing it does better. You guys like, stop. I don't even know what you're talking about, Jeff. Just do what you're going to do. All right. Watch this, guys. It's going to be so exciting. Whoa, look at that. So now this is going to be the highest point. This is annoying. All right, Jeff. It was not a bad idea, but it's annoying. All right. I'm just going to go back to freehand in this bad boy. I really want you guys with me. So then this would be maybe here, and then it was like, and then it goes like here, and then it goes here, and then it gets really tiny there. All right. Does that look normal at all? Does that look normal? This one.
No.
No, it looks skewed. To
Did it right?
right. Okay. Thank you. Not normal. Because why did this guy not have a chance to be normally distributed? Because his mean was too small. Was there room for it to grow and then shrink? Was there room? No. Here's 0 and here's the freaking mean. Hello. I really want you guys to get this. Why was this one so normal? Because the mean is in the middle. It's got room to grow and then room to shrink. Yes, yes, yes. All right. Let's see if I can do this one more time. Ah, shit, Jeff. All right. It's okay, Jeff. You'll be fine. All right. Let me change my color here. Stay with me. Stay with me. Stay with me. What if instead I had something that was weighted 0.9, right? Then the mean would be 14 times 0.9, which is 12.6. Yes. Don't take my word for it. You never know. So then the highest peak would be at 12. You could have done it. See, it's not that bad, Jeff. And it would have the same problems, wouldn't it? Just the other direction. That doesn't look normal either. Yes? Maybe? Maybe? And do you guys notice? All right, stay with me now. So it seems as if for a binomial distribution to be normal enough, its mean has to be somewhere in the middle between the lowest 0 and the highest, in this case is 14, right? The mean has to be somewhere in the middle so that it has room to go up and it has room to come down. Let me stop for a minute. Or not even in the middle, it just has to be far enough away from the walls. Far enough away from the walls. I have no idea if you guys are with me or not. So this mean is too close to that wall, and this mean is too close to that wall. So there's no room for it to go up and then come back down. All right. So what does all that mean? Good Lord, look at this mess. Okay. Let me clear all this away. What that means is this. I forgot to do this. One other thing, but that's okay. What that means is if n times p, which is the mean, yes? If n times p is at least 5, that means that the mean is out to there, yes? So that has room to grow. So if the highest peak was at 5, it would have room to grow and room to shrink. It would still be approximately normal. So if NP is greater than or equal to 5, and NQ is greater than or equal to 5, that actually controls the other side. Then it's normal. So this takes the place of this. This is if I'm talking about sample means. This is if I'm talking about sample percentages. And to be honest, if I'm talking about sample percentages, then I actually need this, little hats on these bad boys. So I cannot, so n greater than 30 is only when I'm talking about a problem dealing with means, dealing with sample means. If I have a problem dealing with percentages, I need to check these two things. All right. How you guys doing? You're like, oh, I love Mondays, Jeff. All right, I understand. So what the hell? Let's has everybody got that written down? That's huge. I hope you understand this is huge. As big as n greater than 30 was, and that's huge. This is just as huge. All right, so I'm going to stop sharing. Here we go.
Wait, I don't have it written down yet.
Oh, I'm sorry. So this is the main thing right here. You got it?
Yeah, I just got it.
Okay, all right, here we
Thanks.
go. Sure. So let's see what this means specifically for this problem up here. Oh shit. Oh yeah, that's right. God, I scared myself. All right. Oh man, past Jeff just likes to play pranks on future Jeff. All right. So let me do this. I want to keep this here. I'm going to move this over here so we have it to reference. All right, so we've got that bad boy. Can somebody tell me what's n in this problem?
78.
Good. It's not 68, right? 78. That's the total number we talked to. Let's see if you guys remember. What's x in this problem? How many
Number of
successes?
people.
The number of successes.
Yeah.
So how many successes do we see?
68.
68. Good. Can somebody tell me what is the percentage that I get from what I see? Don't tell me 95. That's how confident we want to be. What is the sample percentage? What do I see from my sample? I talked to 78 people. 68%. I'm sorry, 68 are going to get vaccinated. What percentage is that?
87.
How'd you get that? How
Sorry,
did
would you divide 78 by 68? No. Oh, other way around.
Yeah. Now, guess what? It's got to be at least 3 decimal places.
87.2.
All right, I like it. Now let's do the check. Let's do the check that we just talked about. Let's verify this is normal enough. If it isn't, I can't do shit. So it's
I have a
all
question.
open. Yes, sorry.
Why is it 68 divided by 78?
I really, all right, I might have made it too technical with the X's and the bullshit. If I talk to 78 people and 68 of them say yes to the question I ask, what percentage said yes? So how many people said yes? 68. Out of how many?
78.
Good. So that's exactly how wouldn't we say 68 out of 78? And isn't that mathematically what 68 out of 78 means?
Oh, okay.
That's
Okay.
all a percentage is. That's it. It's this part divided by the whole, right? That's all a percentage is. I love it.
Thank you.
You're welcome. Now, what do I have to check to know I can use this? I have to check, well, what's n times p hat? Well, let's do it the long way first, and then I'll show you a shortcut. N was 78. What do you get when you multiply 78 by p? 0.872. Oh shit, left off by 2.
68.016.
Hopefully somebody out there is not surprised that we basically got 68. I don't know. Again, there's nothing wrong with doing this, but do you notice? How did we figure out p hat? Didn't we do x divided by n? This is just a shortcut. So if you're cool with what we did there, you're fantastic. You're fine. Here's a little shortcut. Isn't p hat going to always be x divided by n? So what is n times p hat? Isn't it equal to x? Did I have to do that work? No, I can just see it's 68. I like it. So again, you can just do that work if you want to, or you can just realize the answer staring you in the face. Now, what is q hat? No matter what clothing they're wearing, P and Q always have to add to be what?
100.
100% or 1, right? So if P is 0.872, P hat, what's Q hat?
0.128.
I love it. So if P sock was 0.4, Q sock is 0.6, and there's no P sock, just so you know. Don't worry. Not that I know about. That's another article of clothing you want to stay away from. All right. So now I've got confirmation. No, I don't. I still have to do what? What's NQ hat going to be? Well, if you do the work, 78 times 0.128, what is that? Because that's N. And Q hat is 0.128. So what do you get when you multiply those? Not surprisingly, you get
9.984.
Oh, sorry. 9 point who?
984.
984. So it rounds to 10. Isn't that if 68 of them are the successes, then 10 of them, the other 10, are the failures. And what's true about both of these? They are, what's important? They are at least how big?
100.
I left myself no space. No, come on. What's got to be true about NP hat and NQ hat?
Oh, they must be greater than 5.
I've already forgotten what this was. Yeah, it's at least 5, at least 5. Check. What does that mean? What does this whole little weird thing mean?
It is normal.
Normal enough. I love it. So it's exactly the same as n greater than 30, just more work. So yeah, it does kind of suck if you're dealing with a percentage problem. To show that it's normal, it's going to take a little more work. Okay.
Wait,
But
how
again-
did we get
Oh, sorry.
0.128?
Oh, so again, no matter what clothing they're wearing, these two have to add up to be 1. So if that's 0.872, the other one's got to be 1 minus that.
Oh, okay, I see.
Genius. All right. So guess what? Now we can finally, do the problem. We haven't done the problem yet at all. Do you guys know that? Now, why is it taking so long? Because I'm stopping a lot and talking a lot. So a problem's not going to take this long. But let me make myself a little bit of room here. I have no room anywhere, so it doesn't matter. Okay. I'm going to erase this. 95% confidence interval. Can somebody please? Well, I don't think I've shown you guys this, have I? Did I show you guys? I don't think I showed you this. All right, let me show you some kind of neat on the z-score chart. I really appreciate you going on constant adventures with the way I teach here. Hold on. There's a neat little thing on the z-score chart. I call it the baby chart. So yes, there's a song that goes with that. It goes, baby chart. All right, sorry. Right down here, little tiny baby chart. Confidence level. Does this look familiar? 90% confident, 1.6 for 5. Don't you guys remember that? We've done that before. If I want to be 95% confident, it's actually 1.96. And if I want to be 99% confident, it's 2.575. So what if I ask you for a 98% confidence interval? Can you use this? No, you got to do it the old-fashioned way. Ah, ha, ha. So you know I'm going to do that. Right? But this is nice. This is the most commonly used confidence levels. And there you go. All right, so now we got the z-score for the formula. Here's my formula. So I know p hat, 0.872, give or take, z, 1.96, times the square root of p hat times q hat divided by n. So as always, I would highly recommend you figure out the error first. So let's see what we get for this error. I think it's going to be on the bigger side. Yeah, maybe it's not too crazy. Let's see.
Where did 1.96 come from?
That's what we just did. So on the
Oh, the z-scores?
the little baby chart,
Uh-huh.
it's the quick way to get the z-score. Remember, what's the old-fashioned way to get it? The old-fashioned way to get it would be to say, okay, this is 95% here. That's 0.025 out there, right? Is that okay?
Yeah.
There's 95% in there, must be 5% on both sides, 2.5% on that side. So then if I looked at it, let's just see if that little baby chart is trustworthy. Maybe it is not trustworthy. So if I look up 0.025, look at that. It's perfect. And what z-score is that? That z-score is negative 1.96. Holy shit. You guys okay with that? You guys with me out there? Hello? Okay. So this is useful, but it's not always useful. Again, if your teacher is evil like me, I will ask you to calculate the 97% confidence interval. So you can't use that little baby chart. Too bad. Ha. All right. So now, can somebody, this is all about, can you put this in your calculator correctly? Let's see what you guys get for the error. Oh, not too bad. Does anyone have an answer to this part yet? What's the error?
I got 0.0733.
I got 0.0741. That's interesting. So did I do it right? Yeah.
I'm gonna double check.
128.78, right? Yeah. So it should be 0.0741. So like plus or minus 0.0741. All right, so let me know if you cannot get that number from this. Please let me know. Here, even if you don't let me know, I'm going to show you how to do it anyway. So I have a feeling some of you guys don't like to talk to me. So I'll just show it to you.
Are we rounding at all during like during getting the answer till the end? Oh, never mind.
Oh yeah, I've rounded like crazy, haven't I?
No, yeah,
that-
well,
Yeah.
at the end.
I think she means when putting it in the calculator to find out the error, because I got a slightly different answer as well.
Yeah. What'd you
I
get?
got-
You get 0.073 something?
I got 0.7448.
Interesting. Did
I
I?
got the same thing you did.
All right, so let's see. Are we ready? Ready? So here's the 1.96 times. Here's the big deal with this. Now, if you have, all right, I'm going to do this twice. If you have the newer operating system on your TI calculator, you have a square root that kind of grows as you put more shit into it, right? Or stuff. Sorry, if you're offended easily. So 0.872, if you're offended easily and you're still in this class, I don't understand. So 0.128, right? 0.872. And see how the square root symbol is just growing with me? So I know exactly what's in it. Divided by 78. So there's the answer I got, which is the right answer. No, but I make mistakes. So now let me show you what it looks like if you have one of the older calculators. Oh shit. It'll look like this. You'll have a square root symbol that doesn't grow. It has a parenthesis. Do not close the parenthesis until you've gotten everything that's supposed to be inside the square root. The biggest mistake I see is people close the parenthesis too soon, and then everything else is not in the square root. Does that make sense? How many of you guys have a square root symbol that looks like this? It doesn't grow.
Mine's like that.
Yeah. You can check if you hit the mode button, if you see math print as an option, that's the way you can make it look like that. Ooh, if you don't have that option, then you have an older calculator, which I don't blame you for that either, because they're cheaper. Okay. So is everybody able to get that answer now?
Yes.
So that's, all right, so normally it would be plus or minus 3 or plus or minus 4%. Does anyone have a theory as to why this is 7.4% basically? The error plus or minus 7.4%. Why is it such a big error? What do you think? What would we do to make the error smaller? What's the most immediate thing we could do to make the error smaller? How can we be more sure about what we find? If we're doing a study, what do we have control over? What's the very first thing we do?
Sample size?
Yeah, if we increase the sample size, the error will be smaller, which makes complete sense. The bigger your sample, the more certain you should be about what you find, correct? And the math actually agrees. Way to go, math. Good job. See, it does a good job sometimes. So what's the sample size in this problem I just created?
$78.
78. Is that big? Well, some of you guys might, I don't know, Jeff, but it's when you think that Gallup, normally pollsters take about 1,000 to 2,000 responses. That's a normal size poll response. Are you guys with me? And I've seen some go up to 4, 5, 6,000, but they're at least around 1,000 to 2,000. So 78 is crazy small. So of course the error is going to be bigger than normal. You guys semi with me out there? A little bit, not really. You lost me at hello. Okay. And now I just do the same thing we did before. I don't know if anyone's done this yet, but I just take this minus this and this plus this. So maybe you guys can help me out.
0.9461 for addition, and then for subtraction, it's 0.7979.
And then we gotta write our, you gotta do your favorite thing. We gotta write the conclusion. I'm sorry, I'm coming right into your room. I'm sorry. Stop doing that. Get up there. So we gotta write the conclusion. For every confidence interval problem, we have to write the conclusion. So we are what? Farmers, no, we are how confident?
95% confident.
That what?
But the average is between the intervals of 7. No.
No.
That's the true
Dude.
percentage of
Ah.
people who will be vaccinated.
Closer, but not right. So I
At the interval of
at the interval?
of 7 or 0.7979 to 0.9461%.
See how I'm underlining? So when you're talking about percentages, changing it to percent is the equivalent to giving me units. You always have to give me units for these, right? So change it to percentages. So we're 95% confident that the interval 79.79% to 94.61% contains the true percentage of people who will get vaccinated. Now, if herd immunity is 75%, is this evidence that we will reach herd immunity?
Yes.
Yes, because we're going to go, this is evidence that we're going to go beyond 75%. If people do like they say, right? Okay. All right, so let's do the, oh, Jeebus. It's stuck on you. Get away from me. Okay, I can't handle technology and I can't handle a chair. This is good. So let's go back to this dolphin handout. Let's see what's on the other side of this weird ass thing. Let's see. So if you got your dolphin handout, this guy from last time, on the other side, not surprisingly, is a problem about this. So go ahead and do this problem right here. I'm gonna check, somebody's texting me like crazy. Holy shit. Oh, okay. So normally I'm kind of nice and I have a part of the problem that says this so that you don't forget to check those. But on this problem, I was kind of evil because I asked you for a 96%. Gonna sort of start to catch up to you guys. Now, if you do these the long way, you get, I don't know. Let's see. Yeah, you'll get like 459 point something, right? Blah blah blah. But basically, it rounds to these, and that's at least they're each at least 5. So that means it's normal enough. So then I'm allowed to do this next step. Okay.
Can you do one of them the long way?
Oh, yeah, sure. So NP hat would be 652 is N. P hat is 0.704. And if you do that, you get 459.008. Right? So then the other one would be NQ hat. Throw the old calculator. You'll get 192 point something or other. Right? Is that all right?
I'm still working it out.
Okay. You'll get 192.992, I think.
I got that too.
Sweet. Does somebody think that they've found the z-score we need for this problem?
I got 1.75.
How'd you do it?
Me too.
I that's a good question. Even I forgot how to do it. Hold on. I did I'm sorry, I can't even think right now, but that's what I got. I forgot what I did. I'm having a brain fart. This is so
Help me out. Right up here. Is this cool? This is what the 96% confidence interval looks like, right?
Oh yeah, that's what I did. I looked for the point. I looked for 96%, so 0.96 on the chart, and I found that it was.
No, you didn't. No, you didn't. Be careful. That
Okay.
might be so. That might be wrong then, because I can't remember what it's supposed to be honest. It should be 2 point something. So watch, if you look up 0.96 in the chart, you're going to find the z-score that has 96% forever below it. Is that what we want? No. We want the two z-scores that have 96% between them. If there's 96% in here, what percentage is out here on one side? 96% inside,
2.
2% on either side. Look up 0.02 in the body of the z-score chart. That's an area, right? So tell me if you get 205. I think that's what it's supposed to be. Now watch real quick why that makes sense. Did we just do the 95% confidence interval? Wasn't it negative 196 to 196? Yes? Right? Or no, on the board. Yeah, I knew we had just done it. Up on the board. Did we do the 95%? Wasn't it 1.96? Yes? Yes. Okay, you stay with me, stay with me. If I want to catch 96%, don't I have to go out a little bit further to catch 1% more? So then I know my z-score should be bigger than 196 for this problem, which is why 205 makes sense. Did you guys get 205? Anybody?
So you're saying that we don't look for the 0.96 on the chart. We look for anything that's outside of it.
Because confidence interval means that percentage is caught in the middle. When you look up 0.96 in the chart, you're looking up this situation. This is not 96% caught in the middle. This is 96% totally on this side. I really want that to make sense. That's why the z-score chart is one piece of paper, two-sided, because it doesn't do much, right? The minute you're not talking about the area below, you've got to do some work. I really want you guys with me on this. That z-score chart is so small because it doesn't do much at all. So we got to go, oh shit, stupid z-score chart. I want 96% between. So how do I make you understand it? Oh yeah, there's 2% below this z-score. So then I can look up 2% to get this z-score. And since this is symmetric, if that's negative 205, then this is going to be positive 205, which is where the plus or minus comes from, right? In the equation, it's the going up and going down.
Okay, makes sense now.
I like it. I got one person on my side, maybe some more. Okay. So now I know my z-score is 2.05. Again, don't put a negative on it. It's built in. All I really care about is what the number is. It's 2.05. So now I can say we found 0.704 in our sample, but we know that's probably wrong. So give or take 2.05 of these. And then you figure out what the error is and blah, blah, blah. This error should be closer to 4%, I think, because our sample is bigger this time, 652, right? I think it'll probably be, why even guess, Jeff? I don't know. Why not guess, Jeff? I'll say 4.5%. Let's see what it is. I have no idea.
I got 0.0366.
Ooh, neat. Smaller than I expected.
Same as for me.
I underestimated this problem. It seems I have underestimated you, problem. All right. So it's be 0.0366. I like it. And then you just do the same thing. You add it, you subtract it, you get your interval, you say your we are blah, blah percent business. Okay. So then you'll go from point 338. Is that what it is? No, Jeff, you're so wrong. Good Lord, Jeff. That was embarrassing. I'll live somehow. Okay, try it again, Jeff. So this will be 0.6674. Is that right?
Yes.
Okay. See, it's fine to make a mistake. 0.7406. Is that what that is? Good Lord. I can't keep my eyeballs straight. All right, look at me go. Look at me go. All right, now take a minute. Try to write the conclusion. And I'll just sit here. By the way, we'll end class here pretty soon. All right. We're doing pretty good. We're all right on track.
I'm sorry. You really threw me off with that Z-score thing.
Which Z-score
So
thing?
if it was 97%, let's just say it says 97. So then we would look for the 0.01 on the outside rather than look for 97 in the chart.
Hold up. No. All right. So if it was a 97% confidence interval, there's 97% inside. How much is outside?
So it'd be 1.1.
Stop. Say again. Sorry. All right. Just do this for me. 97% in the house. How much outside the house? If 97% is in the house, what percentage is out? 3%. What's half of that? Because I only want this side.
1.5.
Yes. So we look up 0.015.
0.015. So
And whatever that Z-score is, the other one is the positive of it because it's symmetric. Boogie, woogie, woogie. Right? It's symmetric. Boogie, woogie. No? Okay. Is that not done anymore? The electric slide? All right. Anyway. That's how you do any confidence level if you can't get it a shortcut way, like the little baby chart that I showed you.
So if it's two of the numbers, like two Z-scores, do I do, like this one be 2.96 or 2.97? Do I put 2.965?
Oh, wait a minute. All right. Are you looking up this?
Yes.
All right. So something's gone not quite right here. To answer your question, yes, you would do it right in the middle. But if it really is right in the middle, but you shouldn't be getting that. You should be getting, so let's see, 0.0, I think maybe you looked at 0.0015?
I did.
So we want 0.015, which is perfectly right there. Look at that. And that is a Z-score of 2.17. So then I would have put 2.17 in for the Z-score if it was a 97% confidence interval. And why does it make sense? Because if I want to be a little more confident that I caught something, I have to catch more stuff. So therefore, my net has to get a little bit wider so I catch more stuff. Okay. Where did this go? There you are. I have no idea what you guys can see right now. Okay, there it is. So we are 96% confident that what?
The interval of 66.74 to 74.06. I don't know.
Now we're 96% confident that the interval 66.74 to 74.06% contains the
percentage.
Yeah, true percentage or proportion, yeah, contains the true percentage of people that voted.
Would it be of people that voted or the people that voted in the last election?
In the last election, I like it. But if you just said people that voted, I'd be happy with that. I mean, I just need more than stopping here. Look, I got numbers, Jeff. Oh, okay, you got numbers. Great. What do they mean? That wasn't supposed to be what you sound like to me.
That's what I sound like to me.
It's funny you say that. I remember the first time I recorded a lecture and then I had to look at it so that I could put it up. I'm like, really? Is that what I sound like? Oh shit. All right, let me see. Yeah. Who wants to do this next time? Who wants class to end right now?
Can we end class right now, please?
No, I'm joking.
Like with that.
That's the meanest trick question ever.
It's nice though, because I'm actually going to end class now. So yeah, we'll do that one next time, and that'll lead us into section 8.2. So don't forget. Oh shit! I need to go update this. All right, this is good. I'm gonna. Did anyone want to start the quiz right now?
No.
Huh? Yes.
No.
No. All right. I'm gonna make it. All right. I have to add a formula to the formula sheet. I think you guys will be okay with that. So I'm gonna take it down for a minute and then I'll put it right back up if anybody wants to start it soon. Oh, I gotta also. I'm not gonna identify you by name, but I will do the accommodations for one of you. I just remembered. I'll do it right now. So if you're looking for the quiz, it'll be accessible in about 10 minutes.
I had a question about corrections on the midterm. Is that done deal now that this quiz is up, or?
No, corrections are due the day of the final.
Okay, I thought that it was like after the next quiz.
I might say that on the syllabus. I keep forgetting. I gotta do an
'Cause I
updated
remember-
syllabus, but I changed it to the day of the final. Yeah.
Okay, cool. Thank you.
Sure. All right, guys. Anybody have any questions? Anyone need to hang out for a bit?
Quiz is due tomorrow, right?
Say again.
Quiz is due tomorrow?
Quiz is due tomorrow night by 6 p.m.
Oh, okay. Thank you.
You're
Are
welcome.
we gonna have any more questions similar to the question 97 that we had on 7.3?
No. I was gonna say that's all I put on there. No. 97 is definitely a weird one, but it's just good to see that those exist. But yeah, no, the quizzes are always more standard stuff.
Awesome. Thank you.
Do you have a video for the quiz practice
Yeah.
quiz? Okay,
Yeah,
cool.
it's up there. Yeah.
Thank you.
Oh shit, let me see if I can get this to fit. Oh shit. Let's see. All right, everybody's good. I'm gonna head out. See y'all later.